So now we'll see the next concepts, that is measures of location. So measures of location and variability. Why these two are important concepts? What are these concepts? See, when you are given a data set, okay, you plot a distribution for it. Okay, this is the frequency. Frequency means repetition, and then say this is my distribution, how it looks like. Okay, so now these are the points, data points that I have plotted like this. Okay, one point is here. This is the frequency, how many times they have repeated. This is the distribution, what you call as the distribution. Okay, we'll learn more on this in chapter 5 and chapter 6. So now let us say, so this is the average mean. So this is called as location or measures of location, okay, of central tendency. This is called central tendency, the middle point. So there are two measures of locations. One is the sample mean point, another is the median. Then now this is the central point, the central tendency, what we call. Now the points are distributed across this side and this side. So the spread is called as the variability. How the data is spread from the central tendency is called as the variability. Again, there are two measures that we'll be learning here. One is called as the variance and another is called as the standard deviation. So now we'll see to find the what exactly it means, all these means, and then how to calculate them. Okay. Let's start with the measures of location. The first measure of location, what is this? Measures of location describe the central tendency. Central tendency of a data set. The two most commonly used measures are sample mean and sample median. These values summarize the data set with a single representative values. So what exactly these all four, what you are learning 1, 2, 3, 4 are, basically they characterize, they are used to characterize your data set. So based on these values you infer some results, okay, about the data that you have got. Now we take the first one, sample mean. So it is, see, there are two things here to understand. One is sample, another is population, as discussed in the previous lectures. So be careful, like what is the term I am using, sample mean. Okay, it is the mean for the sample. If I say population mean, then it is different. So now let us see how to calculate the sample mean. Suppose the observations in sample are x1, x2 up to xn. There are n sample size. Sample size is n is the sample size. That means how many samples items it contains or data points it contains. Then the sample is computed as sum of all the items divided by number of items, that is sample size. So x1 plus x2 plus x3 up to xn divided by total number of items, that is sample size, will give you the sample mean. So how will you write mathematically? So summation means sum of all. Sum of what? Starting from I equal to 1, then n. So instead of x1, x2, x2, xn, I'll just replace it as xi, right? Xi. I is starting from 1 to n. So just I can write xi. And then the average, that is divided by n. So I'll write it outside. So take the sum and then divide it by n. That is the meaning. So basically it gives the arithmetic average of the values. So let us take a simple example. 5, 7, 9, 4 and 6. These are the samples. That means this is x1, this is x2, x3, x4, x5. So sample size is n is equal to 5. 5 items are there. So that is nothing but summation of all these divided by 5. So we will get the answer as 0.2. Next, why you use it? What is the importance of sample mean? Okay. The sample mean is sensitive to all data points and is a good measure when data is symmetric and not heavily skewed. It is used in many statistical methods, including confidence intervals and hypothesis testing. That is the importance of mean. But when the mean should be used? When the distribution or points are symmetric. That means they look something like this. They are symmetric. See, if I take this as a mu, okay, so you'll see the points distributed evenly. That is symmetric. They both are symmetric to each other, right? This, so you can apply mean. This is a good measure only when the data is symmetric. If the data is not symmetric, that can be skewed. Skewed means something like this. Okay, so central tendency is here, but the variability is very high. Okay, the spread is very high on one side, and another side it is less. So this is not symmetric, right? So you should not apply this if the data is, the variability is very high. Okay, so in that case you can go for sample median. What is median? So how will you calculate the median? Given set of n observation, that is sample size is n, and it should be arranged in increasing order of the magnitude. So if I give numbers 5, 1, 6, 2 like this. So to calculate the median, first you have to arrange them in order, that is 1, 2, 5 and 6. That is what they are saying. So x1 less than or equal to x2 less than or equal to xn in that increasing order. In that case, sample median is given as this x tilde symbol. Okay, x bar means, so this should be tilde, okay here. So x bar means average. So and there are two cases here now, because if I have even numbers, the sample size n value is even, then I have a different formula, because whatever median is, sample median means what? Basically you are finding the middle value. You are finding the middle value in the sorted array, or in the sorted, the data items are arranged in a sorted way, increasing order. So if it is, if n is odd, then you can definitely find the middle element. Why? See, if I have arranged like this 1, 2, 3, 4, 5, 6. Now how many elements are here? 5 elements are here. N equal to 5 is odd. When it is odd, the middle element is easy to find. This is the middle element. This will be the median. Now if there are even numbers, n, if I take it as 6, now it becomes even. When it is even, I cannot find a middle element exactly. So I have to take the average of these two. That is what it says. When n is even, you take xn by 2, then xn by 2 plus 1. So I will get, and then take the average, half of it. This is average 1 by 2. What is n by 2 here? N is 6. N by 2 is 3. So this is the third element, right? So 3 plus xn by 2. 3 plus 1. This is the fourth element. So 5. That is what we have to find. Average it will be 4. Now the sample median provides a measure of central tendency location of the data. It also provides the central tendency, that is something like mean, but it can be applied when you have data is asymmetric, okay, contains outliers or in a skewed data. So the skewed data, what it is, you'll understand when I explain the variability. Next, so a simple example they have taken here. So let us take n equal to odd value initially. N is odd, so median will be n plus 1 by 2, right? X n plus 1 by 2. So that is n is 7 plus 1, 8 by 2. So that is x4 is the median. Fourth observation, that is this observation. Similarly, if I take n equal to 8, then I should take the two middle values and then take the average. What are the two middle value here? So 9 and 11. So x4 plus x5 divided by 2. That will be 10. Next we go to measures of variability. Just as there are many measures of central tendency location, there are many measures of spread and variability. What is this variability? Usually shows how spread out data points are from each other and the center. Together, central tendency, it summarizes the data set. That's what I told. Basically, measures of central tendency and measures of variability gives you the characterization of the data set. So, central tendency shows where most values lie, whereas the variability shows how far apart they are. Okay. Low variability means more consistent data, easier to generalize to population. High variability equal to less consistent data, harder to predict. Common measures, range, variance, and standard deviation. So let us try to understand. So this is how your distribution looks like. So this is what is called a symmetric distribution. Symmetric means mean equal to median equal to mode. That means data is very symmetric. Variability is less. So when I say mean, median, mode, so mean already understand. Median, mode means the frequency. Okay, what is the frequency of each data point? So if they are all are equal, then it is symmetric. If mean is less than, median is less than mode, this is how your distribution is skewed. This is called as negatively skewed distribution. That means mean is less than, median is less than mode. Mode is highest, mean is less. Your mean is exactly here. Okay, this is called as negatively skewed distribution. If it is the other way, mean is greater than, median is greater than mode, then it is called as positively skewed distribution. So now you will see what are the measures of variability. The first one is sample variance. So sample variance measures the average square deviation from the mean. It is denoted by S square. Please remember this, and is defined as, it is defined as the square of the differences of each data point minus the sample mean, then square of it. Okay, and then divide it by n minus 1. This is nothing but what? Xi minus x bar whole square is I can be 1 plus x2 minus x bar whole square plus so on up to xn minus x bar whole square. So divided by n minus 1. Why not n? Why n minus 1? This we will see when I teach you the central limit theorem. This actually n is called as degrees of freedom. Degrees of freedom. So more on this concept we'll learn later, but please remember this is n minus 1. This is called degrees of freedom, df. So take a simple example. So what exactly it helps? It reflects the overall spread in the data. Fundamental inferential statistics, including hypothesis testing and confidence intervals. These are all things you're going to learn in your 7th and 8th chapter. Okay, don't worry about it. So for the given sample data, first you find the sample mean. You get it as 7. Then you calculate xi minus x prime whole square. You will get it as 20 and divide it by number of data points, 4 minus 1, 3. So 6.67 you get. These are simple things. Next, what is standard deviation? The standard deviation is nothing but the square root of the variance. Square root of the variance is standard deviation. So S square is the variance. So square root of this is nothing but the standard deviation. So this is the formula for variance. Take a square root of it. Why it is used? It represents the typical distance of data points from the mean value. When I take a standard deviation, this is my distribution. This is my say central tendency. This actually standard deviation will give me what? Yes, right? Standard deviation in this representation. So this is minus S this side. This is plus S. It gives how the data points are away from the central tendency. In the previous example, you take the square root, you will get the standard deviation. Now, that's why I ask you to remember that we are dealing with sample. Now we will come to the population variance and population standard deviation. So sigma square represents the population variance and sigma represents the population standard deviation. Everything remains the same. When I say x bar, it's sample mean. I told in the first video also, sample mean. When I say mu, I'm saying it as a population mean. So when I'm calculating population variance and population standard deviation, I have to use the population mean, not the sample mean. So similarly, if there are xn points, okay, and sample size is not here, population size is n. capital N, population size, entire population I'm talking about. I'm not talking about a sample. N, small n means sample size. Okay, we'll summarize it later. So let us understand that. The formula remains same. Only thing here is it is not n minus 1. Be careful. There it was small n minus 1. Here it is capital N. Why so? I told you, I'll explain in the central limit theorem. So when I explain you the t distribution, student t distribution, there I will explain why, what is the small n and what is capital N, why it is small n minus 1. Okay, so now let us understand in general and in practicality how they are applied. The sample variance and sample standard deviation both measure how spread out data is. Variance uses squared units. Okay, so because you are squaring them, right? Minus x square whole square, like this you are doing. But standard deviation is taking the square root. So if the units here is centimeter square, it will be centimeter here. Why both are important? They help understand the variability in the data. Variance is used more in statistical theory. So when you devise a model, mathematical model in statistics, we usually use variance because it helps us to model it easily. Whereas when you apply your model in practicality, in real world, we usually go for standard deviation. Okay? So you may be asked in some interviews or somewhere, both are same. Why use? Because variance helps us in statistical estimation. When you work in mathematical model, variance will be easy to use. When you apply that in your practical solutions, then you will use standard deviation. Okay, so why you need all this? See, population mean and population variance is what we want to estimate, right? This is actually exact statistic. That's what I told in the last video. So we want to see how the population mean and variance are there based on the sample we take. So sample variance helps estimate population variance with sample standard deviation is used with sample mean, okay, x bar to estimate mu. These are the things we will learn in central limit theorem, how you going to estimate. Basically, if you remember that, what you are doing, you are estimating this population mean using some error. This some error is nothing but this or this. S means sample standard deviation, this is population standard deviation. Based on these two, we are going to estimate this. This is the goal of your statistics. So now to conclude, okay, please remember this. I have given sample and I am given a population. Now so size, how will you write this size? Okay, sample size or population size. Then you have mean or average. Then you have variance. Then you have standard deviation. So you represent it as n, small n. In my textbook, I represent it as small n, and most of the textbooks also they use small n for to represent sample size. Whereas the population size is represented by capital N. So how you represent mean? Mean is equal to x bar. Okay, this is nothing but summation of I equal to 1 up to n xi, okay, 1 by n. This is how I calculate the mean. So here we represent it as the mu 1 by n summation of I equal to 1 to capital N, then xi. Variance you represent as s square. So how it is represented? 1 by n minus 1 summation of I equal to 1 to n xi minus x bar, that is whole square. Here it is represented as sigma square equal to 1 by n, not n minus 1. Then summation of I equal to 1 to n xi minus xi minus mu, the population mean. Then standard deviation is represented as s. That is nothing but square root of 1 by n minus 1 summation I equal to 1 to n xi minus x bar whole square. Here it is represented as square root of sigma, that is equal to 1 by square root of 1 by n sigma I equal to 1 to n xi minus mu. Okay. Please remember this. In the problem, you just observe whether they are mentioning it as sample or the population. Based on that, you apply these formulas. Okay. We'll see some more problems, simple problems. Quickly we'll finish them. Find the sample mean. Okay, they are saying, please observe the sample mean of the data. That means this is the sample mean. So x bar equal to 5 plus 7 plus 3 plus 6 plus 9 divided by, what is the n value here? 5 divided by 5. We will get it as 6. Okay. Next, calculate the sample variance of the data set. Sample variance. Okay, again sample variance. So first you have to find x bar, that is 4 plus 8 plus 5 plus 3 divided by n is equal to 5. So x bar comes out to be 5.2. Now how will you find s square is equal to 1 by n minus 1, okay, summation of I equal to 1 to n xi minus x bar, that is 4 minus 5.2 whole square plus, okay, so remove this into it. So you go on calculating like this, 8 minus 5.2 whole square, like that. So we will get s square as 3.7. Then similarly, sample standard deviation. So first find x bar. So x bar will get it as say 12.8. Then you calculate s square using that formula. So here n is 5. So we will calculate by using n minus 1. Okay, summation of I equal to 1 to n xi minus x bar whole square. So you will get x square as 3.7. Then s is equal to square root of 3.7 standard deviation. So we will get it as 1.92. Okay. Similarly, find the population mean. Population mean is presented as mu. 6 plus 9 plus 5 plus 8 plus 7 divided by capital N is equal to population size is 5 divided by 5. So you will get it as 7. Next, find the for the population. Already we are mentioning population. Find the population variance. Sigma square is equal to 1 by n summation I equal to 1 to n xi minus mu whole square. So what is mu value here? The average. So mu value will get it as 6. So then you will get sigma square as 2. Okay, just try it out. Similarly, find standard deviation. Sigma to find. So n is equal to 4. Sigma is 1 by n square root of summation of I equal to 1 to capital N xi minus mu. So what is mu here? So mu is sum of all divided by number of items, that is 13. So and you will get sigma as square root of sigma square, right? So that will be equal to 2.24. So variance will be equal to square of this, that is around 5. Okay. So that completes your introduction to statistics. From the next video, you will see the most important concept in the GATE, that is the probability theory. Please subscribe, like and share with your friends. Okay. So we will see in the next video starting with the probability theory.